All right, everybody. So let's take a look at our very last topic in hypothesis testing. This is one of those topics that, in theory, is always present when you perform a hypothesis test. And I hope that, this little introduction makes it clear why that is. In an exam, I would really only ask you to identify the kind of error possible and then find the probability. So you don't have to know everything there is to know about type 1, type 2 errors, but I do want you to be aware that there is a subtlety in hypothesis testing. So just based off of the reading here, we can see that the evidence we collect is based on our sampling distribution. So the evidence we know is simply taking a sample. So when we take a sample, we're going to assume that we have the sampling distribution. So we know that the samples behave according to this curve right here, the sampling distribution. When I take a single sample, and we've observed this before when we did chapter 8, we are more likely to obtain samples that land very close to the middle, but we also understand that samples that don't land close to the middle are perfectly valid samples under that sampling distribution. Now, here's the issue, though. You will sometimes, because of this variability, get a sample that is very far away from the true center, even though everything else went, perfectly right. So you might end up with this sample. So this sample is valid, but if you do happen to be unlucky and obtain the sample as part of your sample, then you will reach the wrong conclusion and say, hey, that sample mean is pretty far away from the true mean. So therefore, we're going to reject the null hypothesis and support the alternative. And that is clearly the wrong conclusion, because we've said that, assume that the distribution is true. And what this is showing you is that even if H0 is actually true, you may get samples that land very far away. So this is an example of a very simple error. So the takeaway from this video is that we will sometimes reach the wrong conclusion, even if everything else goes exactly as planned, right? We set up our null hypothesis. We take a simple random sample, but lo and behold, our simple random sample results in this sample. It's very far away, it lands in the critical region, and therefore we're going to reject the null and support the alternatives. This is an example of something called a type 1 error. So type 1 error is literally the fraction. We can see it right here. Type 1 error is the fraction of samples that will land very far away from the center, even when we know that that center is the correct center. So it describes exactly this behavior. So type 1 error is literally alpha. It's the probability of landing in those tails. So we've seen that one before. And remember, we said, we recognized ahead of time that, if this is our distribution, we want to essentially determine at what point would a sample be unusual. So we're not saying the sample is impossible. We're just saying this sample here would definitely be unusual under the null hypothesis. In other words, the true center is actually mu naught, this center right here. Now, here we can visualize it, and we've seen this before, that if you take sample after sample, you will land close to the middle. So, for example, this one lands somewhere here, somewhere here, somewhere here. But the fifth sample, unfortunately, lands very far away. So way too far away. So if you obtain the sample, your hypothesis test will reject the null hypothesis. If you create a confidence interval, your confidence interval does not contain the claimed center. So in both instances, you will reject the claim that the true mean is actually mu naught. So that's a type 1 error. That one's very easy to remember because we've always essentially drawn it. So let's go ahead and fill in this little table that will summarize what we've just explained. So here we've got two possibilities. We've got a column here that says, in reality, this is what's true. This is unknown to us. So this is what would happen if you had complete information. In other words, you know the true center, the true standard deviation. In other words, you don't need statistics for this because you already know what is true in reality. So this is something that we don't have, right? It's inaccessible to us. And it's this reality that it's really simple to determine, is the mean or the parameter really what they claim to be? So is this correct or not? Well, because you know what the true mean is, you know right away whether that's true or not. So in this reality, we can go ahead and say, okay, now what happens if the null hypothesis is true? So let's go ahead and focus on this column. And again, remember, that means that the null hypothesis is true. So for now, let's just say that the center is right where they claim that it is. All that we have access to is the sample. Our conclusion will solely be dependent on one of these samples. Again, we're not going to do this many different times. We're only going to take one sample. And here in this case, I land in the fail to reject region. A confidence interval would contain the true mean, the claim mean. So in this case, I would go ahead and say, do not reject the null hypothesis. So that's what would happen there. If I get that, I don't know what color that is, that light blue color, then that would indicate do not reject the null hypothesis. In reality, I know that H0 is true, so I don't want to reject it. And so therefore I reach the correct conclusion. So I'm happy. Now, what would happen though if we end up with this orange sample out here? That could be my sample. And then based off of that sample, which again does follow this distribution, I would land in the rejection region. My confidence interval does not contain the claimed center. So in this case, I'm going to reject the null hypothesis. And again, if I reject the null, that is based on a single sample, in other words, incomplete information, I'm going to make an error because in reality, we said H0 was true. So this would be a type 1 error. So that's unfortunate. We're reaching the wrong conclusion. And let me kind of stay with this right now. If the null hypothesis is really true, then you're only going to reject the null if you happen to land here, if you get a sample here or here. And if you guys remember, anytime I shade, that's a probability. So I know from the way that I've been setting up my hypothesis test that the area in that tail is alpha. Alpha is always the point at which a result becomes unusual. So we're actually saying if the null hypothesis is true, if my samples really do follow this distribution that I'm looking at, then only 0.05% of my samples, if I repeatedly sample, will result in me rejecting the null. And so that's why type 1 error, we can actually control that, and we're going to call that alpha. So alpha is our probability of making a type 1 error. So alpha is the probability of rejecting the null when the null is true. And this is something that we can control because we've always stated alpha ahead of time. We said at the significance level, we always said at what point is a sample going to become significant. So that is something that is under our control. Let's go ahead and move on into the second case. This one is a little bit different. Let's see if we can make sense of that. Let's say that in reality, the null hypothesis is false. So it's this case. The null hypothesis is false. You should not fail to reject. So you shouldn't really be landing somewhere here. You should be landing in the tails. So let's try and stay with the same color scheme. Let's say that in reality, the null hypothesis is false, so you want to reject it. But let's say you land with the blue sample. Blue sample's here, and that's fail to reject the null. So because you do not reject the null, but the null is false, you've made a mistake. And what kind of mistake is that? Well, that's called a type 2 error. This is a little bit harder to understand, but just for now, say type 2 error happens when you do not reject the null, when the null should have been rejected. Okay, so that's more or less the idea of why I have this little graphic here. You're going to work with this graphic for the next couple problems. All right, now for the next one, let's say that you reject the null when h0 is false. So you end up getting, like, for example, x5. That's in the critical region. That's reject the null. The null is false, so you really should have rejected. And so in this case, you are happy because you got the correct conclusion. So you can see that this little graphic summary tells you when a type 1 error happens. Try and memorize the type 1 error. Type 1 error just basically says everything is working as it should be. Nobody's lying to you. The null hypothesis is true, but you just got a sample that's very far away. And we've always shown that using alpha. So that one's pretty easy to understand. The other kind of error that could happen is if you fail to reject the null. So you do not reject the null, when in reality, you should have rejected the null. So even though the center is somewhere else, you still got a sample that appears to be consistent with the null hypothesis. So that one's a little bit harder to memorize just because there's a lot of negatives. You fail to reject the null, even when the null should have been rejected. It's a little bit easier to understand type 1 error. Part of it is that because we've always sketched that type 1 error. Remember, it means you just land very far away just due to random variability, even though you should have landed in the center. So let's just fill in type 2 error. Type 2 error is denoted by beta. So beta is the probability. And we're gonna, at the very end of these notes, so notice how lengthy these notes are. At the very end of these notes in the last video, you will see how to finally compute beta. It's easy for us because we have StatCrunch, but otherwise it would be very difficult. But the probability of failing to reject the null hypothesis when the null hypothesis is false. That's what a type 2 error is. Let's go ahead and just practice. So let's do this one example. Let's explain the error that's possible and try and refer to this little graphic here. But hopefully you are trying to memorize it. If h0 is true, then you want to, the only way you can make an error is if you reject the null. All right, so here's a really non-statistics example. Suppose that your friend just fixed your car brakes. So car brakes are pretty important, right? Stop your car. So the claim is your friend fixed the car brakes. So therefore, we're going to say that the null hypothesis, H0, is that the car is going to be safe to drive. You can go ahead and see, like, what is the alternative very quickly. So hopefully your friend knows how to fix the brakes. Then that would make the car safe to drive. Otherwise, the car is not safe to drive. All right, now what does it mean to make a type 1 error in this context? And I always memorize the type 1 error as alpha. Just remember, it's the tails. So it means that you land in the tail, and remember, it's an error. So if you don't land in the tail, you're going to land here, you fail to reject the null. But if you land far away, then you reject the null. And here they're saying you're making an error. So alpha is when you make an error by landing in the tails. Alpha, type 1 error, is a mistake landing in the tails. So the mistake is that you reject the null, because the conclusion is reject, right? But they're saying that that's a mistake because it's a type 1 error. So if I land in the tail, that's alpha, and the claim is that I reject H0 and therefore I support H1, this is a very serious error. So what does making a type 1 error in this context makes? It means that my sample evidence or my evidence, whatever evidence it may be, maybe it's an inspection, or you just take it for like a trial run. So it basically says there is evidence to, oh no, my bad. This is not a serious error. Type 2 error would be very, there is evidence to, and we said support H1. So you don't want to say support H1. We're going to say there's, or if you want, we can say there's evidence to reject H0 when H0 is actually true, right? So that's more or less going to be true for, this is the definition of a type 1 error. Now let's interpret it. So now that we've got that out of the way, let's go ahead and summarize this in context. There's evidence to reject the null. So we're going to say evidence indicates, we're going to reject the null, so we're going to support H1, which means there's evidence indicates that the car is not safe. So again, this is supporting H1. So there's an issue with the brakes. But remember, this is a mistake. The evidence tells me reject H0, but in reality, the car is actually safe to drive. And so in the purple, we have summarized what the error is in context. This is something that you want to learn to do. And really, we do that by memorizing the whole reject H0 when H0 is actually true, and then you just summarize it. Notice how this is not that big a deal. Okay, you have reached the wrong conclusion, but driving the car when it's not safe, I mean, you could die or you could kill other people. So this just basically means that there was something that, again, the evidence, whatever it may be, it was an inspection, something didn't look right, something didn't feel right, and you're just like, you know what, the car is not safe to drive. But in reality, it really is safe to drive. So that's just being overly cautious. Okay, so in the real world, usually this is the way you want things to operate. This is like overly cautious. Right? That weird noise or that weird feeling, that weird look that, you know, the mechanism gave was enough for you to say, you know what, I think we need to check it again. And so this is how a lot of systems operate to reduce system failures. Now, let's go ahead and take a look at what a type 2 error means. Type 2 error in this case would mean that and again, I'll start out with the blue. So you're making an error, not by rejecting the null, but by failing to reject the null. And if you don't remember, that's okay. Just go back up here. And so a type 2 error happens when the null hypothesis is false and you fail to reject the null hypothesis. So notice that each one of these scenarios, each one of these columns only has one type of error. So type 1 error is very easy to remember. That's the error that you make by rejecting the null, just landing in the tails when H0 is true. So type 2 error happens when the null hypothesis is false. So we're going to say the evidence, or there is evidence to fail to reject when H0 is false. All right, now let's try to interpret this one. We'll do it in purple. So we're going to say evidence. So again, we're failing to reject the null. So if we fail to reject the null, that means that all of the evidence indicates that the car is safe to drive. Right? So we fail to reject the null, but in reality, H0 is false. The car is not safe to drive. So we're going to say evidence indicates. So notice that we fail to reject the null. That means we cannot support H1, which is that the car is not safe to drive. So evidence indicates that the, what's it called? That the car is safe to drive. So in other words, the brakes are fixed even though the brakes are not working. So let's just summarize it by saying this car is not safe to drive. And there's our first example of interpreting type 1 and type 2 errors. In the next video, we'll go ahead and take a look at the next couple examples.